This meeting is being recorded.
In problem 10 from chapter 12, we are asked to look at these transformations and then identify whether or not our starting material has been oxidized, reduced, or neither. So we have three options to choose from. And we're asked to try this without calculating an oxidation state. And then we can go back and use some calculations to see if we intuit the right result here, if it was oxidized, reduced, or neither. So I'll show you how we can accomplish both of these methods. So in part A here, we're going to focus on this carbon atom here whose bonding pattern has changed. So this carbon originally was bonded to two other carbons and then to an oxygen with a double bond. In our product, we see that carbon still has 4 bonds total. Now to 2 chlorines instead of to the oxygen. So the oxidation state we can predict would not change for that carbon because it still has the same amount of bonds, it's still sharing the same amount of electrons, and we haven't increased the amount of bonds to oxygen, right? So this is another generalized way to see if oxidation state would increase. So if we increase the number of bonds to an oxygen atom, we would increase oxidation state. Or if we increase the number of bonds to hydrogens, we tend to decrease oxidation state. So we'll say oxidation number. So this carbon we're going to predict is not changed, is neither. Let's take a look at B and see if we can predict something similar. So let's focus on the carbon that has a change made to it. So our starting material has a double bond to an oxygen, and then single bonds to carbon and hydrogen. In our product, we see that double bond to oxygen hasn't changed, nor has the single bond to carbon, but now we see an additional bond to oxygen. So we'll predict that this guy has been, our starting material was oxidized rather. In our third compound, what do we see? We see a change here. So in this scenario, the carbon has lost 2 bonds to oxygen. This carbonyl is no longer there. So since we decreased the number of bonds to oxygen and increased, right now we have more bonds to hydrogens here. So by the same token, we've increased hydrogen bonds. This compound or this starting material would have been reduced by our prediction. In part D, what do we see? We see we had a chloride. We have an oxygen atom here in place. So our prediction would be that this carbon would be neither oxidized or reduced. That was the same for our first prediction here. So neither for A, neither for D. And we can confirm that with oxidation state calculations. Let's take a look at E. In E, we have a single bond between this carbon and oxygen. Now we have a double bond, so we've increased number of oxygen bonds. So this guy is most likely oxidized. And let's take a look at our last scenario here. So this carbon has increased its number of oxygen bonds. So we would predict that this is oxidized. So let's work through A here and see if we can recall our rules for how to assign oxidation states. So in a compound, we'll solve for our carbon here. So it's bonded to oxygen twice here. And if we were to calculate our oxidation state when it's bonded to these two chloride ions, if you recall, chlorine is a halogen, and that has a -1 oxidation state in a compound, and oxygen, when in a compound, has a -2 oxidation state. So if we were to compare these two, we could see that changing from 1 oxygen bonded to our carbon to 2 chlorines bonded to our carbon will not affect our oxidation state on that central carbon atom. We could do something similar over here with compound B. So again, we'll solve for that carbon, and we see that we have gone from 2 bonds to an oxygen to 3 bonds to an oxygen here. So if we were to solve for these neutral compounds, solve for the carbon, we would know that we've added an additional -2 oxidation state here, whereas hydrogen in a compound is generally a +1 oxidation state. So we would have to increase the oxidation number of our carbon in order to retain a neutral compound. So again, you can either calculate or look at the specific bonding pattern and note that when we increase bonds to oxygen or a decrease bonds to oxygen, we can affect oxidation number the most obviously way. So increasing bonds to oxygen, we increase oxidation number. And then like so, if we increase bonds to hydrogen, we would reduce our compound and decrease the oxidation number.